Check, check, check. Here we are back again with Geometry, Chapter 6, Section 4, the Triangle Midsegment Theorem. Okay, so here's a triangle, and on sides A, B, I've marked the midpoint between A and B. So these two parts would be congruent, right? Midpoint of a segment, and same thing here. Now, if I connect these two lines, cool thing that happens here, that line that connects the midpoints ends up being parallel to the third line. So that's a cool feature. Another cool feature here, if you look at this, if I connect from here to there, whoop, like this. Oh, let's try to make that match up. There we go. And then I duplicate that. Notice if I put that down here, swoop, duplicate, look at that. That length down there is exactly 2 times the length of that midsegment. So, the midsegment is the segment that connects the two midpoints, and the theorem here, we know that it's parallel, and also that the midsegment is 1/2 the length of the third side there. Okay, that's Theorem 6.8, Triangle Midsegment Theorem. Okay, and every triangle, if you connect all the midsegments, every triangle has 3 midsegments, and if you connect all those points, it makes what's called the midsegment triangle. All right, using these, here we have triangle JKL, and we want to show that the midsegment MN is parallel to, this here is parallel to JL. All right, and we want to show that MN is 1/2 of JL. All right, first thing we're going to do is parallel. In order for 2 lines to be parallel, their slopes need to be the same if we're on a coordinate grid. So I've got J, -6 and 1, and 2L is 2 and -1. I will check their slopes. From 1 to -1, we go down 2. From -6 to +2, we go up 8. So the slope here is -2/8, which is -1/4. Okay, and then here, M looks to be at -4 and 3. -4 and 3. All right, -4 and trace. And then N is at 0 and 2. 0 and 2. Okay, from 3 to 2, we go down 1, -1. From -4 to 0, so right there to 0, we go up 4. So we have equal slopes, therefore parallel. MN is parallel to JL. Okay, very nice. Next, I want to determine that MN is 1/2 of JL. In order to do that, I'm going to do the distance formula. That means I will set up a distance formula, distance between the two, change in the y's, squared plus the change in the x, or it does the other way around, doesn't really matter. X1 minus x2. Again, and the order of that doesn't matter either because we're squaring them. Plus the change in the y's, y1 minus y2, squared. Okay, so for my segment MN, that is 3, 3 and 2, 3 minus 2. If I want to square that, that's 1 squared is 1, plus, oh sorry, that was the y's. Let's move that over there. Okay, and then the x values, -4 and 0. So -4 minus 0 is -4. Square that puppy, and we get 16. 16 plus 1 is 17. So we've got 17 here. That is radical 17. All right, so MN, the distance MN is radical 17. Now we want to do the same thing for JL. we have the y's. I'll start with the x's. -6 minus 2 is -8. Square that, we get 64. And then the difference of these, 1 plus 1 is 2, or minus -1, that's why I'm doing plus. We got 2, square that, we get 4. Add those, we get 68. Alright, now, we can split this up a little bit, and that's actually 4 times 17. And so I can bring the same as 4 times 17. And I can find the radical of 4, which gives me 2, and radical 17. Like so. So, notice that this segment is 17, and this is 2 times 17. So JL is 2 times MN, which makes JL half, which makes, yes, MN half of JL. There we go. Alright, if we want to use it, very easy, very fun to use. We want to find UV, this segment right here, and RS, this side right there. And we know that these are mid-segments. UV is a mid-segment, and VW is a mid-segment. Okay, so we'll find UV first. We know that RT is 90, and by the triangle mid-segment theorem, UV is 1/2 of RT. Alright, that is triangle mid-segment theorem. Okay, and so therefore UV equals 1/2 of 90, which is 45 inches. That was easy. Alright, let's find RS. RS is this line right here. And we know VW, we know that RS is 2 times VW, because triangle midsegment says that VW is half of RS. Right? And therefore RS is equal to 2 times 57. Therefore RS is 114 inches. That's a 14, not a 19. There we go. Ah, that was fun. All right, moving on. See what else we can do with all this newfound knowledge. All right, we know that AE is congruent to BE. So this segment right here is congruent to this, which makes E the midpoint of the two. AD is congruent to CD. AD is congruent to CD, making D the midpoint. All right. Since D and E are the midpoints, so this means D is midpoint. Midpoint. Definition. And here, AD, C. Other way around. Rushing here. E is midpoint. On this one, D is midpoint. Okay. And since E and D are the midpoints, that makes DE the midsegment. Therefore, DE is parallel to CB, because triangle midsegment theorem. Ah, that was fun. Okay, let's see what else can we do. Alright, Pear Street intersects Cherry Street, boom, and Peach Street at their midpoints. Ah, important information here. Midpoint right there. Midpoint, midpoint. Your home is at point P. You leave your home and jog down Cherry Street. Okay, we're going all the way to Plum Street, so we're going this way. Doo-doo-doo-doo-doo, jogging this way. And then we're going over Plum Street to Peach Street. Doo-doo-doo-doo-doo, jogging that way. From Plum Street to Peach Street. Zippity-doo-dah, having so much fun jogging. And up Peach? No. yes, Peach Street to Pear Street over Pear Street. So now we're going to take a turn, going this way, and then to Cherry Street, and then back home up Cherry Street, this segment right here. And then we're home. Okay, how many miles did you jog approximately? All right, let's see. We went from Cherry Street, then plus Plum Street, and then we went up half of Peach Street, half of Peach, then we went down Pear, and then we went up half of Cherry. Half of Cherry. Okay, we know that half of Cherry is 1/3, so Cherry Street is 2 times 1/3. Okay, so Cherry Street is 2 times, not 1/3, 1.3. Plus Plum is 1.4. Plus half of Peach, 1/2 of 2.25. 25? I'm having a little trouble drawing here. Pear is half of Plum because midsegment. So half of 1.4 and half of Cherry is 1.3. Tally all of those up and you have run approximately 7 miles. Well done. Good run. Should keep you in shape, get you prepared for cross-country season. That was all the fun we're going to have with this lesson. Check back again next time for another fun lesson in geometry. Good time.